Hello, Patrick and colleagues. Thank you very much for arranging this segment with Harvey and Charlie and myself. I'm actually overseas at the moment, so I'm sorry I cannot join you live, but it's great to join you via video. So, hepatitis C, I can't believe it's 31 years ago since we published our back-to-back papers with Lim Chu and George Kuo and Dan Bradley and other colleagues, showing that we had identified hepatitis C virus using a cDNA immunoscreening method. And the second paper described the first hepatitis C virus antibody test, showing with colleagues all over the world that Hep C was the major cause of blood-borne hepatitis non-A, non-B. Time flies when you're having fun, and I want to acknowledge the key roles of Dr. Lim Chu, Dr. George Kuo, and Dr. Daniel Bradley on the work that we did together identifying the hepatitis C virus. Well, we have very good antivirals now. We have had very good diagnostics and blood screens tests for a long time. But it's very important we close the loop and develop vaccines against hepatitis C, because history tells us that infectious diseases persist even when cheap therapeutics are available. The hepatitis C antivirals are very effective, as we all know, but they're not cheap, and they're unlikely to be cheap in the future. Even when they are cheap, this is a slide I borrowed from Dr. Stephen Schafran at the University of Alberta. This is showing over a 20-year period in Canada, there was a huge increase in the incidence of syphilis in both males and females between around 2000 to 2011. Actually, between 1993 and 2000, it was fairly constant at a low level, and then there was a huge incidence in the country, even though we have very cheap therapeutics and effective therapeutics to control and treat syphilis. So this is an example, I think, of why we definitely do need a vaccine against hepatitis C. As you know, or most of you know, my colleagues and I have been working on the concept that recombinant E1 and E2 envelope glycoproteins made in CHO cells from the virus are likely to be an effective vaccine. And to my knowledge, recombinant E1, E2 combined with an adjuvant is still the only hepatitis C vaccine candidate proven to be efficacious in chimpanzees. So over the course of many years, we vaccinated animals 3 times, and then we challenged them either with homologous virus, from which the vaccine was made from, or heterologous virus. Both of the strains were 1A genotype, which is the most common genotype in North America. And you can see that there was a significant reduction in chronicity, whether we challenge with homologous virus or heterologous virus. And we use unimmunized controls, and you can see, for example, against homologous virus, 70% of controls develop chronic persistent infection. Only 17% of the vaccinated animals develop persistent infection. And when we challenge with heterologous H77 virus, supplied by Harvey and Bob Purcell, in the vaccinated group, we saw 16% only develop chronic persistent infection, whereas 57% of unimmunized controls develop chronic persistent infection. As you all know, it's the chronicity of HCV that's associated with the clinical sequelae. And so preventing chronic infection is the main goal. And you can see that we did this quite effectively with adjuvanted E1, E2. And this was reported in a Nature review that I wrote with Sergio Abrignani. And also I updated more recently, 2011, in Immunology Reviews. So this is a very good candidate as a vaccine for Hep C. My colleague John Law at the University of Alberta looked at antisera from human volunteers in a phase 1 trial that we had vaccinated with adjuvanted E1/E2. And he asked the question, can the antisera neutralize the different genotypes of Hep C? And using the CC cell culture system developed by Takagi Wakita and Jens Book and colleagues, John was able to show that at a 1 in 50 dilution of the antisera from the vaccinated people, we were able to see significant neutralization of infectivity with all the major genotypes seen around the world. For example, individual number 5, the red is 1A, the orange is 1B, yellow is 2A, green 2B, 3A, 4A, 5A, genotype 6A, and genotype 7. So this was a very important finding because even though the vaccine was made from a single strain, which was the H77 strain, which is a 1A genotype, the E1/E2 obviously has highly conserved neutralizing epitopes, and that with E1/E2 and adjuvants, we are able to elicit neutralizing antibodies to multiple cross-neutralizing epitopes, and that's why we can see neutralization of all the different genotypes. So this was an important finding, and currently we're manufacturing our vaccine under GMP at the University of Alberta. Unfortunately, a lot of this work was done a long time ago at Chiron and Novartis, and unfortunately Novartis prioritized influenza and meningococcal vaccines over hepatitis C vaccines. So unfortunately there was an interruption of the clinical development of E1/E2, which I picked up at the University of Alberta, and we're currently manufacturing it. We're adding some highly conserved T-cell epitopes as well to the vaccine, because we know that correlates of protection are neutralizing antibodies as well as T-cell responses. And so I think this has a very good chance of working. And just a note, apart from the urgent need to prevent the 2 million or so infections of HCV around the world every year, as estimated by the WHO, it's also highly cost effective. If we just provided the vaccine to high-risk people in Canada, the cost would be around $20 million versus 1 billion if we were to treat the carriers. So this is a highly cost-effective situation. I just wanted to thank all of my many collaborators in Europe and all over the world. I've had some excellent collaborations, very important ones. I'm not going to attempt to name everyone because I know I'll leave someone out and offend someone, but truly, I really am grateful and acknowledge the key collaborations with so many Europeans, Americans, all over the world. And also, it's very mind-boggling to think that I've been working on Hep C for the last 39 years. But not as long as Harvey, so that gives me some encouragement. Anyway, thanks again, Patrick, for inviting us to talk. Sorry I can't be there with you live. I'm actually overseas right now, and but I'm glad to be able to contribute by Zoom video. Thanks again, and take care, everyone.